Let's see what is quantum mechanical model of an atom. The structure of the atom, subatomic particles, how uh, protons and the neutrons are there in the nucleus, and how electrons are revolving around it. What will be their velocity? What will be their positions? How will we will relate the spectral lines formed by them to the absorption, the absorption and emission spectra. How is that related to the structure of the atom? The way in which electrons are revolving around where they are actually. It's all that the model of atoms that we have been discussing right from J.J. Thomson, then Rutherford, then Bohr's model, then de Broglie's wave, behavior of matter, then the Heisenberg's uncertainty principle. Now we are going to study the structure of the atom, which is based on the quantum mechanical model, and it all started from there will be a new form of physics called quantum mechanics. So mechanics is what it's a part of a physics or mathematics which deals with the motion and the forces which produces those motion. It's applied mathematics, branch of applied mathematics or branch of physics, which deals with the objects which are in motion, the forces which are applied and the effects that those forces produces. And so mechanics. Now we're going to there's like classical mechanics, which is in which we generally study the Newton's laws of motion, uh, and these laws are very well able to define the properties and how they will behave when force will be acted on it, like on falling stone or on the orbiting planets, like like the second law of Newton's laws of motion, which defines force as a product of mass and acceleration. Like these are what we study in classical mechanics, and they are very well able to uh, to to define or to predict the positions, the velocities, the acceleration, the mass, the force acting on them on big bodies like stones, the cars, planets, rockets. But when it comes to smaller subatomic particles, macroscopic objects which we are not able to see, that like electrons and all, the classical mechanics fail to define them, to understand them, or to describe them. So what comes into picture is a new model called quantum mechanics, which is a theoretical science which deals with the motion of macroscopic objects, because this will consider the dual nature of matter, which was propagated by de Broglie through its famous equation where he gives the relationship between the wavelength, the Planck's constant, and the wavelength and the momentum, which means that every object, whether big or small, will have a wavelength which will be inversely proportional to its momentum, mass multiplied by velocity, and the uncertainty principle, which says that it's impossible for microscopic objects. It's impossible to determine both the position and the momentum with the same precision at the same time. At the same time, it's impossible to determine the position and the momentum with the same accuracy. That is called the Heisenberg's uncertainty principle. So it's like considering the wave and the particle nature of everything, including the electrons, the quantum mechanics will be able to define, to give a clear picture of how atoms are, how electrons are arranged around it.